When you perform a global analysis of a steel structure, it is common to assume that the connections between the members are rigid or pinned. This is a choice you make in the global analysis based on engineering judgment, and it is generally a conservative approach. Sometimes, though, there is flexibility in the connection between the members that you can take advantage of, if you can quantify the stiffness. It gives you the ability to optimize with regards to weight, utilization, and cost. So how do we do this? IDEA StatiCa has a stiffness analysis function that helps you determine the stiffness of the joint and thus validate the global model setup. The output and results of the stiffness analysis is the moment rotation diagram and a table with several values. Based on the curve and a selected standard, IDEA StatiCa assigns a stiffness class to the joint, pinned, semi-rigid, or rigid, and this information can be used as feedback to your global model to further increase the accuracy. I will give you a quick demo that illustrates most of the things you need to know about stiffness analysis, and after the demo I will also let you know what additional information you may need to consider. So let's go to the demo. Here is the global model. In SAP 2000 we now have two simple frames where the bottom one has rigid corners and the upper one has pinned corners. So if we run the analysis with a evenly distributed load on the top beam, then we can see that the results are quite different. In this case, we will export one of the frames and look at the joint, and we will design the joint in IDEA StatiCa and find the rotational stiffness and then input it back here to SAP 2000 and the global model. So first of all, I will run the checkbot to export the frame. I will create a new project, and next step is to select in my FEA software which frame I would like to export to the checkbot. So now I can hit import connections and the frame will be imported. And at this step I now want to design these two upper connections. They are here, and to make the design process even faster I can group these two similar connections into a group one, and the underlined connection is the mother connection and the child connection will be designed similar to the mother one. So I will select it and open it into IDEA StatiCa connection. So here is the connection with the correct cross sections, and at this point I would like to apply a design. So I can either manually build up the connection with plates, bolts, welds, and so on via these manufacturing operations, or I can use the connection library with a design that I've already made. So I hit propose and I can find this design. This is suitable for me, and at this point I would need to choose which steel quality and which bolts I would like to use. So I will use the M18 bolts and the S355 steel quality. So I also want to adjust this connection a little bit. So the end plate I would like to set the thickness of 10 millimeters. And now I would like to assess the stiffness of this connection. So I will go to the connection, the node 13, and switch from stress-strain analysis to stiffness analysis. Now I have to choose which member should be analyzed, and I choose the M9 member and hit set analyzed. Next step is to input the correct loads or load cases, and here I would like to only put a moment and a shear force, and in the next load case I would like to only assess the shear force, the moment, like this. So now I have one load case with moment and shear force and one load case with only moment. So there is some recommendations from IDEA StatiCa that you should consider the load case with only moment, but for many reasons I would also like to assess the load case with the moment and shear force. So I will hit calculate and perform the stiffness analysis, and the program will apply the loads and draw out the diagram for the stiffness analysis results. Now the analysis is completed, so we can go over to the Check tab to look at the results. And in the Check tab, we will now find the rotational stiffness and a table with all of the outputs and also the diagram from the stiffness analysis. So in this table, there is a lot of useful information, like the initial rotational stiffness and the second rotational stiffness, and also, most importantly, the class. So we see that these connections, or this connection, are classified as semi-rigid. So we should input the initial rotational stiffness into the global analysis model. So we will jump over to SAP 2000, and now I would like to compare the results that I retrieved from IDEA StatiCa with the pinned and the rigid model. So I will input the rotational stiffness to these connections. So the value of 2.3 meganewton meters per radian I input here, but with some different units, and I can now run the analysis again. And now we can clearly see that there is a difference between the rigid one and the semi-rigid one and the pinned one. So if I bring up the values and the deflections, if we review and compare these three cases, then we can see that the middle one with the semi-rigid connections has different results. The moments in the corners, they are of course different. They are about half of the rigid connections. So this can give more flexibility on how to design a global model. It will also make the results different over the whole structure and how the forces move through the structure. So this is definitely something you need to consider for some cases. And the next step is then to synchronize the checkbot model so that you can have the new forces applied to the connection, and then you can run the connection design. And by the way, here's a bonus tip. You can actually use the member application to help in your stiffness analysis assessment. Let's open this frame structure in the member application. So I will add a new member in the checkbot, and I will choose the analyzed member and hit space or enter. And I can now see that I also have a member structure. So I can open it in the member application. And for those of you that are not familiar with the member application, it is for looking at stability sensitive members. So you can check out buckling, lateral torsional buckling, and stability of beams and columns. And you also have the ability to do a full analysis with geometrically and nonlinear analysis with imperfections. So here I have the structure, I have the beam, the related members, the connections that I already designed. I will now make sure that the supports are rigid for the columns, the bottom of the columns, and we can now run the analysis and compare the results, so the moment diagrams typically, with the results that I have in SAP 2000. So now we can look at the internal forces, and if we compare this to the results that we have in SAP 2000 in my global model, we will see that they are fairly similar. So I have 16.2 kilonewton meters in the beam, and in the corner I have 6.8. And I can go back to the middle one, so the semi-rigid one, where I actually adjusted the rotational stiffness, and I can see that they are almost the same. And here are some other aspects of stiffness analysis you should consider. When should you use initial rotational stiffness, and when to use second rotational stiffness? What if your structure is braced? Which Eurocode guidelines are relevant related to stiffness classifications? How should you really interpret the information from the diagram? It's not always straightforward. How can you use the member application to help with the stiffness analysis? How to correctly set up the load cases and why it matters? All of these topics are interesting and challenging, but we will not cover them in this quick tip. If you want to learn more, you can contact support or check out IDEA StatiCa's great support center on their website, which has webinars, articles, and more. There should be links to a few of them in the description and on our blog. And of course, we have classroom and online training courses that cover this and other advanced topics. We can also provide company-specific training. Reach out if you are interested. Thank you.